All right, so let's look at 14. We've defined the vertical and horizontal asymptotes and the domain. How do I find a vertical asymptote? We set the denominator equal to 0. So for vertical, set the denominator equal to 0. And then we solve for x. So add 2 to both sides. Subtract 2, sorry. Subtract 2 to both sides. 5x is equal to negative 2. Divide by 5. So x is equal to negative 2 over 5. So this is our vertical asymptote. For the horizontal asymptote, what do we have to look at? So you look at the degrees of the numerator and the denominator. So if the degree of the numerator is greater than the degree of the denominator, then we have no horizontal asymptote. If the numerator is less than the degree of the denominator, then our horizontal asymptote is y equals 0. And if the degrees are the same, then we have to look at the coefficients. So what's my highest degree in the numerator for a? The highest degree. 1, because it would be like x to the first power. And the highest degree in the denominator? 1. So when my numerator and denominator are the same, we take the leading coefficients of both of them. So this will be y is equal to 3 over 5. My horizontal asymptote. Bless you. And then for the domain, what do I have to check the domain here? What can we not have here? We can't have 0 in the denominator. So we would set our denominator not equal to 0. So we'd say 5x plus 2 cannot be 0. So then we solve for x, just like we did when finding the vertical asymptote. So x cannot be negative 2 over 5. Now, if this was written in interval notation, how would we write it? So how can I say all numbers except negative 2 over 5? Perfect. Negative infinity to negative 2 over 5, and then negative 2 over 5 to infinity. Not included negative 2 over 5. So these are the same thing, just a different way of writing it. Let's find the horizontal asymptote for b. What is my degree of the numerator? 2, and the degree of the denominator? So what do we know when the degree of the numerator is higher than the degree of the denominator? No horizontal asymptote. Awesome. So 15, we have to perform the indicated operation and write the complex number in standard form. So we have to simplify our square roots first. What happens if I have a negative in the square root? It comes out and turns into an I, so we can get rid of that. Now, what are 2 factors of 50? 25 and 2. And 2 factors of 25? 5 and 5. So if I have any pairs, I circle them, and they come to the outside. So I already had a 7i on the outside, and I'm taking out a 5. What's left on the inside? 2. Anything that doesn't get a pair stays on the inside. What do I do outside now? Multiply them. If we have numbers on the outside, multiply them together. So it would be 35i square root 2. So that's just the first half. Let's do the same thing for square root 40. What are 2 factors of square root 40? 2 and 20. 2 factors of 20. 5 and 4, we could say that. Or 2 and 10. And then 2 factors of 10 would be 2 and 5. So all your factors should be 2, 2, 2, and 5. What would I circle here? The 2 2's. So 2 2's come to the outside. I already had a 2 on the outside. And what stays on the inside? 2 times 5, which would be 10. So this turns into 4 square root 10. Can I add these together? No, they don't have the same square root, and they don't both have i's, so I can't add them together. When I write this in standard form, which one has to come first? The one without the I. So I would say 4 square root 10 plus 35i square root 2. All right, B looks a little bit different, so let's do this one too. What should I do first for B? Distribute. So I have that -3 that needs to be distributed to both things in the parentheses behind it. So it turns into -24 minus 6i. The rest of it stays the same. What can I do next? Combine like terms. So I'm going to combine all the real parts together. So 4 plus 2 would be 6. 6 minus 24. -18. And then we can add all the imaginary parts together. So 3 minus 4i minus 6i would be -7i. Remember, in standard form, the real part comes first. What happens if I have something like, let's say 5 over 2 minus I? We can't have I in the denominator. What would I need to do here? Multiply by what? Perfect. We multiply by the conjugate, so 2 plus I. And whatever we multiply on the bottom has to get multiplied to the top. So I can FOIL out the bottom. It turns into 4 minus I squared. The top I have to distribute, so that would be 10 plus 5i. What does I squared turn into? -1. So if that was minus -1, it would turn into a plus 1. So 4 plus 1 would be 5. So 5 is our denominator and 10 plus 5i on top. Can I simplify this? How? So I can divide all 3 numbers by 5. I can simplify because 5 goes into both the 10 and the 5. So this would be 2 plus I. So for 16, we're going to use the given 0 to find all the zeros of the function. Well, if I have that -3i is a 0, do I know any other zeros? Positive 3i. Conjugate. Now what should I do next to find the other zeros? So we work backwards. So if 3i and -3i were zeros, I would say x minus 3i and x minus -3i, which would turn into plus. So these are two zeros, two factored parts. How we got the zeros. From here, we want to FOIL. So we are working backwards. So x times x would be x squared. Then x times 3i would be 3ix minus 3ix minus 9i squared. Now the 3ix's cancel in the middle. What does the I squared turn into? -1. So it's -9 times -1 plus 9. So x squared plus 9. So I know x squared plus 9 is a factor. How can I find other factors? Long division. So x squared plus 9 goes on the outside. And this all goes on the inside. So 2x to the 4th power plus x cubed plus 15x squared plus 9x minus 27. Now, you need every x accounted for. So if you start with x to the 4th power, make sure you have 3, 2, 1, and none. If we're missing one, remember you'd have to put a 0x in that spot that's missing. But we have all of our x's here. So now we can go ahead and divide. So what's 2x to the 4th power divided by x squared? 2x squared. So I'm going to put that 2x squared on top of the x squared term. You got to keep our terms in line. Once I divide, we can multiply everything out front. So 2x squared times x squared would be 2x to the 4th power. 2x squared times 9 would be 18x squared. What do I do next? Change the signs. Change the sign, and combine. So my x to the 4th power is cancel. I drop down the x to the 3rd power. And then add the x squared. So 15x squared minus 18x squared. -3x squared. And then we do it all again. So x to the 3rd power divided by x squared would be x. Then we multiply. So x times x squared would be x to the 3rd power. And then x times 9 would be 9x. Change the sign, and combine. So the x cubes cancel. Drop down the -3x squared. What's 9x minus 9x? 0. They cancel. And then we can drop down the 27 also. This would be, actually I'll leave it there for now. Let's do the last step. So we're going to do that all over again. So -3x squared divided by x squared would be -3. Then we multiply -3 times everything out front. So that would be -3x squared. And then minus 27. What do we do next? Change the sign, and combine. So the 3x squareds cancel. -27 plus 27 will cancel also. So I have no remainder. Anytime you do these problems, we know that x squared plus 9 is a factor, so you're not going to have a remainder. If you get a remainder, then you divided wrong or FOILed wrong in the beginning. So you're not going to get a remainder here. So last step is we need to take our result, so 2x squared plus x minus 3, and factor this to find the remaining zeros. How would I factor? Perfect. Multiply the first times the last. So we get -6. What are two factors of -6 that add to 1? 3 and -2. So I have x plus 3 and x minus 2. What do I have to do next? Divide by 2. Step that everybody always forgets. Don't forget, if you start by multiplying, you have to remember to go back in and divide. If it doesn't divide, move the number in front of the x. So it would be 2x plus 3. Simplify if you can. So x minus 1. And then we just set each piece equal to 0. So 2x plus 3 is equal to 0, and x minus 1 is equal to 0. And just solve for x in each little equation now. So x is equal to negative 3 over 2, and x is equal to 1. Because we subtracted the 3. So all of our x's are 1, negative 3 halves, 3i, and negative 3i. Which we started with an x to the 4th power function, so I have 4 zeros here. All right, 17, we have to divide using long division. So if a question like this was multiple choice and it just said divide, you could divide however you want, but if it has 3 terms, if it's a trinomial that's dividing into it, you can't use synthetic division. You have to use long division. So that goes on the outside. 5x to the 3rd power minus 21x squared minus 25x minus 4 goes on the inside. Always double check to make sure you're not missing any terms. I start with cubed, squared, 1st power, no power. So we're good. So we go ahead and divide. What is 5x to the 3rd power divided by x squared? 5x. So I'm going to put that over the x term. Then I multiply. So 5x times x squared would be 5x cubed. 5x times negative 5x would be negative 25x squared. And 5x times negative 1 would be negative 5x. What do I do next? Change the signs. Change the sign, change the sign, change the sign, and combine. So 5x cubes cancel. Negative 21x squared plus 25x squared would be 4x squared. Negative 25x plus 5x would be negative 20x. Now we do it all over again. 4x squared divided by x squared would be 4. So plus 4. So once I write it up top, I multiply it by everything out front. So I get 4x squared minus 20x minus 4. Then we change the sign, change the sign, change the sign, and combine. So the 4x squareds cancel, 20x's cancel, and the 4x's cancel also. So when I divided, I'm just left with 5x plus 4. That's my answer. With no remainder. All right, 18 says use the remainder theorem and synthetic division to find the value of the function. So what's going to go inside of our box for synthetic division? Two, 11, negative 21, and negative 90. All of our coefficients. Make sure that all of your terms are represented. I have x to the 3rd power, squared, 1st power, no power. So we're good there. If we were missing one of our degrees, we would have to make sure to put a 0 in that spot. What's going to go on the outside? Negative 6. You would only change the sign if it gave you like x minus 6, something like that. Because you want it to be like x equals, so this would be like x would be positive 6. So that's why we would change the sign if it's written like this. But it's telling us that x is negative 6 here. Yeah. So drop down the first number, multiply, add, multiply, add negative 21 plus 6 would be negative 15. Multiply 6 times 15 would be 90. Yeah. And negative 90 plus 90 would be 0. So what is the value of the function? What is f of negative 6? Just the value of the function. If I were to plug in negative 6, what's my result? So the remainder is always the result of the function. What's my remainder here? 0. So if I plugged in negative 6 into all the x's in this function, I'd end up with 0. So the remainder is your answer when you're doing the remainder theorem. So show that x is a solution of the third degree polynomial and use the result to factor the polynomial completely. List all real solutions of the equation. So I do the same thing that I did on the last one just to show that 3 is a solution. We need our remainder to be 0 if 3 is a solution. So I put all of my coefficients inside the box. 1, negative 1, negative 9, and negative 9. And 3 goes outside the box. So drop down 1, multiply, add, multiply, add, multiply. We get negative 18. Is 3 a solution? No. Because it says x equals. If it's x equals, whatever it's equal to goes exactly outside. Let's say that it ended up being a solution. How would I find the other real solutions? Perfect. Since I started with x cubed, my answer here would now be x squared plus 2x minus 3, and I would just have to factor this. Because if we end up with 0 as our remainder, then it means that it is a solution. We take the rest of it and just factor it normally. All right, 20 is kind of similar. We're given that x is equal to, or x minus 4 and x minus 3. I guess it says that they are factors. And we have to find the remaining roots, right, in fully factored form. So how can I show that these two are factors? We do the same thing we did in the last one, use synthetic division. But if I have x minus 4, what's going to go on the outside? 4. So we change the sign, because this is like saying x is equal to 4 and x is equal to 3. So let's start with 4 on the outside. And all of my coefficients go on the inside. 1, negative 5, negative 2, and 24. Drop down the 1, multiply, add, multiply, add, multiply. We get 0. So is 4 a solution? Yes, so that works. Now I take the result and do it again with 3. So I'm going to put 1, negative 1, and negative 6 inside the box, and 3 on the outside. Drop down the 1, multiply, add, multiply, and we get 0. So is 3 a solution? Yes. Now we need to see, what am I left with? Well, I started with x cubed, so my first time I did synthetic division, that one would start with x squared. And then the second time, I'd have just x. So this would be just x minus 2, which means what else can x be equal to? 2. So my solutions would be 2, 4, and 3. And to write it in fully factored form, I'd have x minus 4, or I'll list it in order, x minus 2, x minus 4, and x minus 3. The order doesn't matter, but I just wanted to list it in the same order I did here. This was a positive 2, so it should be x plus 2 and negative 2. So our solution should be minus 2 and x plus 2 here. So if it says in fully factored form, it would be like this. So like it's factored out. But if it's multiple choice, then just look at your answer choices. If it asks for the zeros, it would probably be written like this. So if the question said, like, list the zeros, but this would be factored. All right, so 21, kind of moving in a different direction now. Here we have to describe the transformations. So what happens when we multiply it by a negative outside? A reflection on which axis? X-axis. What about when I multiply by 3 on the outside? Does it stretch or shrink? Stretch. What about when we add 4 on the inside? Left 4. And then when we subtract 1 on the outside? Down 1. One way to think about it is, what would my vertex be? Because this is in vertex form, so we can clearly identify the vertex. What would the vertex be? -4, -1. And if I'm moving -4, you'd be moving to the left to -4. Because we flip the sign of H. So it's like always the opposite of what you think for the one that's inside the parentheses. Right, 22. So for 22, when it says write the equation in its equivalent form, we're putting it into, if it's a log, we put it in exponential form. If it's an exponential function, we put it in log form. So here I have an exponential function. I would have to put it in log form. So I start with log. What would my base be? 4. And then I switch the order of the other two. So 64 is equal to 3. Mm-hmm. All right, for B, we do the same thing. Start with log. What would my base be? 5. What would come next? 1 over 125, and it's equal to -3. So you always just flip the other two. Start with your base, flip the other two. C, we're putting it in exponential form. So I start with my base, which would be 4. What's the exponent? 4 to the 3rd power would be equal to 64. Oh, these are supposed to be answer choices. Oh, no. I think the question was written wrong. But,
isn't it like different?
Yeah, they're different. But these two are the same, kind of, but just flipped. It's fine. On the key, they're answer choices. Like, it gives you the question and gives you A, B, C, and D, but these are all different. What's the base here? 5. It doesn't give you a number, but we can say X there. What's my exponent? 3, and it's equal to X. All right, 23, we are graphing. So the best thing to do for graphing would just be to plug in numbers for X and get Y values and just plot your points. So questions like this, a calculator would really help. I'm going to make a chart over here for numbers that I'm going to plug into X. So I would start with like -1. So I would have -3 to the power of -1 plus 2. What's -3 to the power of -1? What does a negative exponent do to the number? It flips it. It makes it a fraction. So this would be -1/3.